infinite possibilities all start with a point in space. Look around you. What do you see? How do you describe it? Geometry explores combinations of points, lines, and planes to investigate and create the world around us. And once you start seeing geometric patterns, you see them everywhere. Because they are everywhere, from the smallest cell to the largest structure you can imagine. In plain sight and hidden in the objects you come in contact with every day. And the way triangles, parallelograms, and hexagons fit together have inspired artists and motivated mathematicians and engineers to discover amazing things that stop describing just mathematical shapes and start describing the natural world.
Suppose you had a gadget that could shrink an object by half or a third just by pressing a button. And what if it had another button that would double or triple the object's size? Imagine how convenient that would be. Carrying your backpack with its back-breaking load just got a lot easier. Zap it a few times and then slip the whole thing into your pocket. And what if a bunch of your friends show up at your house and you only have a medium-sized pizza in the freezer? Just zap it until there's plenty to share. Though at some point the mushrooms would get really big. What a great gadget to have!
You've saved up some money and gotten permission to make some changes to your bedroom. One of your ideas was inspired by the famous Japanese block print, The Great Wave. On one wall, you want to paint a series of large and small waves using stencils. You'll make the stencils based on the original image but in different sizes. Cutting out the stencils for this design is a long and tedious process. When the stencils are ready, you can start painting. How can you use transformations to accurately recreate the pattern?
In the night sky, one group of stars seems to stand out. The Star Finder app on your phone says it's Orion, the hunter. The constellation is easy to identify because of the 3 stars that make up Orion's belt. Alnitak, Alnilam, and Mintanka are arranged in a neat line, or so they seem. In reality, it only looks that way from our perspective here on Earth, looking out into the cosmos. If you could see those 3 stars from a different perspective, you'd find they're really far apart. How could you determine the distance between the stars?
The idea that the Pythagorean theorem has its roots in ancient Egypt is not pure speculation. Papyrus and leather scrolls, some 4,000 years old, hold the key to the importance of triangles in Egyptian mathematics. More pointedly, there is the little matter of the 12-knotted rope.
You need to ask yourself, what are you solving for? You might be able to model the situation with 2 equations and then solve them. Suppose a sprinter on the school's track team and a math teacher decide to race. Oh, this is too painful to watch. What happens if we give the math teacher a head start? It seems like we're going to have to give the teacher a little more help. This time we'll give the math teacher a head start and double her speed. How long will it take the sprinter to catch up with the math teacher? Who will cross the finish line first?
Even Thomas Jefferson developed plans for a checkerboard grid city in the early 1800s. Jefferson's idea was to alternate each block of houses with blocks of open area. Each developed square would be surrounded by 4 park-like green spaces.
Scientists may decide to employ 2 ROVs. In this scenario, they pilot the vehicles in tandem across the ocean floor, which is a challenge for all involved. Unless the paths of the 2 ROVs are continuously monitored, the scientists' efforts may be wasted. They may wind up with conflicting or corrupted data.
Periodically, the ROV paths are monitored by the research boat floating above them.
Pilots need to factor in weather conditions, especially wind speed and wind direction. If there's a tailwind, one that blows in the same direction that the plane is traveling, it can boost the plane's airspeed. But if there's a headwind, one that blows in the opposite direction the plane is traveling, it will slow the aircraft down.
Even if you had a measuring tape with you, there's no way you could climb the skeleton to drop it down. What other methods could you use to measure it? Outside of the museum, you notice another huge object. How would you be able to figure out how tall the totem pole is without using a measuring tape?